Okay, geometry students, this is take 2 of section 2.3. This assignment had some pretty low scores, and so we're going to go over problems from the homework here from section 2.3. Some of this is kind of a repeat of the part you did on Delta Math last week, but based on some of the answers, I think some of you all could use a repeat. So we're going to go over problems together today. So again, 2.3, we're talking conditional statements. Directions say identify the hypothesis and conclusion of the following conditional statements. Some of you guys on your Delta Math homework were still using the words if and then. Those are not in the hypothesis and conclusion. It's just the statement part. So number 1, the conditional statement says if the product of two numbers is 0, then at least one of the numbers must be 0. If we separate out the hypothesis and the conclusion, the hypothesis is just the product of two numbers is 0, okay? And then the second part is at least one of the numbers must be 0. So they are two separate statements without the use of the words if and then. Okay, so the if and then makes them conditional. If we separate it out into the hypothesis, the first part, and the conclusion, the second part, we don't use if and then anymore. Okay, so the second conditional statement, if it is daylight savings time, then I must reset my clocks. So the hypothesis is just it is daylight saving time. And then the conclusion is I must reset my clocks. Okay, it is daylight saving time. I must reset my clock or my clocks. Okay, now this is where they give us a statement and they want us to write this as a conditional if-then statement form. Okay, so we're supposed to write the following statements in if-then form. So a rhombus is a quadrilateral with 4 congruent sides. So what we need to say is if a quadrilateral is a rhombus, then it has 4 congruent sides. If a quadrilateral is a rhombus, then it has 4 congruent sides. Okay, and I use abbreviations whenever I can. So if a quadrilateral is a rhombus, then it has 4 congruent sides. Okay, the next one that they want us to write an if-then form. Those that finish the marathon will get a medal. So if you finish a marathon, then you will get a medal. So if you finish a marathon, then you will get a medal. The next statement, again, an if-then form. All freshmen are required to attend orientation. So if you are a freshman, then you are required to attend orientation. So again, if you are a freshman, then you are required to attend orientation. Okay, now this next part, again, I know it was in Delta Math. Some of them were, but some of you guys really did not understand this. Okay, so when we start with your typical if-then conditional statement, we've got different directions we can go. So we have inverse, okay, which essentially means that you put a not on each of these. Okay, then we have converse, which means you flip-flop the hypothesis and conclusion. We have the contrapositive, which means you essentially take the converse and put a not in each of those. And then the biconditional means it goes both directions. Okay, so again, I'm going to say, I'm going to use a little symbols here, but if you live in Dallas, so you live in Dallas is going to be like my P, then you live in Texas. So say this is my Q, okay? So your typical if-then conditional is P leads to Q, okay? That's what we started with. Your inverse, okay? Your inverse is if you do not live in Dallas, then you do not live in Texas. So your inverse is not P, then not Q. That's how we get our inverse statement. So if I'm just calling you live in Dallas as my P and you live in Texas as my Q, then this is the conditional statement, if P, then Q. Okay, now, first of all, if you live in Dallas, then you live in Texas, that would be a true statement. I hope you all can see that. Okay, now we're assuming they mean Dallas, Texas. So the inverse here, again, inverse statement is not P, then not Q. Okay, so if you do not live in Dallas, then you do not, I don't know what just happened there, then you do not live in Texas. Now, TX is the state abbreviation for Texas. I'm big on abbreviations because it helps me not write as much. So if you do not live in Dallas, then you do not live in Texas. The truth value of that is false, because you could live in Austin. You'd still be in Texas, okay? Or you could live in Houston, or you could live in San Antonio, or you could live in Lubbock, or wherever. Okay, so if you do not live in Dallas, you do not live in Texas. That's false. Dallas does not take up the entire state of Texas. Okay, there's other towns. Now, converse. Converse, you literally flip-flop the P and Q. You flip-flop your hypothesis and conclusion. So converse is Q, then P. Okay, so my converse statement would be if you live in Texas, then you live in Dallas. Okay, now this is kind of goes right along with the one above, same kind of rationale. That would also be false. Okay, if you live in Texas, you do not necessarily live in Dallas. Okay, just for the same reasoning. You could live in Austin or Houston or Lubbock or whatever. I'll just use a different city name. Okay. So that's converse. So if your original conditional statement is if P then Q, your converse is if Q then P. Now, contrapositive, okay, is essentially, the contrapositive is the, I hate to say it this way, but it's kind of the inverse of the converse. So your contrapositive is if you do not live in Texas, you do not live in Dallas. Again, it's kind of the inverse of the converse. Um, so this is if not Q, then not P. That's your contrapositive. If not Q, then not P. So if you do not live in Texas, then you do not live in Dallas. If you do not live in Texas, then you do not live in Dallas. And that is actually true. Okay? Since Dallas is in Texas, if you don't live in Texas, then you obviously don't live in Dallas. It's kind of like if you do not live in Missouri, then you do not live in Concordia, Missouri. Well, obviously that's true. Okay? Now, biconditional. Okay? Biconditional means literally it goes both ways. So this is P to Q and Q to P. Notice the bidirectional arrow there. So these are stated a little differently. We usually don't put if and then. It's we put if and only if in the middle. So you live in Dallas if and only if you live in Texas. So you live in Dallas if and only if you live in Texas. Now, this if and only if part, first of all, kind of a shortcut for writing if and only if is IFF. The higher levels of math you get, the more symbols and shortcuts that you find. Mathematicians do not like to write. So if and only if is usually abbreviated with IFF, and it's essentially a double barred arrow. You can also see that. Okay, if and only if. You live in Dallas, if and only if you live in Texas. Now, the if and only if is different because if you say you live in Dallas if you live in Texas, or actually I should say if you live in Texas if you live in Dallas, okay, that's true, but it's not true the other way. You live in Dallas if you live in Texas. There's a whole lot of Texas that doesn't work. So this is actually false because the converse is false. Okay, what I just talked about. Okay, so one direction is true. You live in Texas if you live in Dallas. That's true. But you live in Dallas if you live in Texas is not true. Okay, so it's only true one direction, not both. In order for a biconditional statement to be true, it has to be true going both directions. Okay. All right, backside. Now these I know you didn't see on Delta Math. I didn't put them in. So let's talk about these. So the statement is, if a number is a natural number, then it is also a whole number. Now let me kind of back up here and talk about natural numbers versus whole numbers. Whole numbers start at the number 0 and go up, and we're just talking like positive integers, including 0. So 0, 1, 2, 3, 4, 5, 6. Natural numbers are also called the counting numbers, okay? And counting numbers start with the number 1. So 1, 2, 3, 4, okay? So again, natural numbers are counting numbers. That's how I like to remember them. Okay, and whole numbers include 0. Okay, so first of all, our statement is if a number is a natural number, then it is also a whole number. Okay, so first of all, let me kind of do the same symbols as we did. A number is a natural number. I'm going to call this my P. Okay, and it is also a whole number is going to be my Q. So this is going to be P, if P, then Q. So if a number is a natural number, then it is also a whole number. And that is absolutely true. Okay, now the inverse of that, remember, inverse is kind of the not. Okay, if a number is not a natural number, then it is not a whole number. So this is not P, then not Q. Okay, so to write it out, if a number is not a natural number, then it is not a whole number. Okay, if a number is not a natural number, then it is not a whole number. Okay, the truth value of that is going to be false. Why? Because 0 is kind of my reason. Okay, and maybe I shouldn't use an arrow, but 0 is a whole number. So, but not a natural number. Okay, so if a number is not a natural number, that could be the number 0, it is still a whole number. Okay. All right, converse. Now the converse, remember, is you flip-flop your P and Q. So converse is Q, if Q, then P. Okay, that's converse, is if Q, then P. So if a number is a whole number, then it is a natural number. Okay, and I'm, again, taking a shortcut here. Instead of writing out the word number, I'm using the little hashtag sign, but it's not a hashtag like a tweet. It's hashtag in place of the word number. So if a number is a whole number, then it is a natural number. So if a number is a whole number, then it is a natural number. And again, it's kind of the same reasoning as above. That is false because of 0. So 0 is a whole number, but it is not a natural number. Okay, 0 is not a natural number. Contrapositive. Now, contrapositive. If you remember, contrapositive is kind of the inverse of the converse. Again, bad way to say it, I guess. But this is if not Q, then not P. If not Q, then not P. So if a number is not a whole number, then it is not a natural number. If a number is not a whole number, then it is not a natural number. Okay? And that would be true. Why is that? Because if something's not a whole number, it's either a fraction or it's negative, and none of those are natural numbers. All of the natural numbers can be encapsulated inside the whole numbers. Okay, when we talk about Venn diagrams, when we get to section 2.4, you'll see what I mean. Okay, biconditional. Now remember, biconditional means we go both directions. Okay, so biconditional statements means if P then Q and if Q then P. So we go both directions. Okay, but we don't put the if and then in it. We put if and only if in the middle. Okay, so again, we have arrows going both ways. So a number is a natural number if and only if it is a whole number. So a number is a natural number if and only if, again, if and only if, that's the key phrase you have to have in the middle. If and only if it is a whole number. Okay, and once again, this is false because the converse is false. Okay, so if a number is a natural number, then it's a whole number. That's true. But if a number is a whole number, then it is a natural number is not true. Okay, so again, it goes one direction, but it does not go the other. Okay, last section. Once again, you all will notice here that I am covering every one of these. So on your homework for today, it is literally going to be you watching this video and writing these notes on the piece of paper for your homework and turning that into me, just like it was on yesterday's assignment for 2.2. I'm going to see who all is actually watching the videos all the way. Okay. So the directions on this part, write the appropriate statement to match the symbolic notation using the statements to the right. Then classify it as the conditional, inverse, converse, or contrapositive. Now, I intentionally did what I did on the first two sections, number 6 and number 7, with writing the little symbols out to the side just to kind of get us ready for this part. Okay, so this one is P to Q. This is right off the bat. Well, I should probably use a different color, but this is the conditional. Okay, that's what we started with on our number 6 and 7 above this one. Okay, so if you have a library card, then you can check out books. If you have a library card, then you can check out books. That's conditional. Now, not Q to not P. Not Q to not P. That's the one that I said is kind of the, what I say, the inverse of the converse, okay? Not Q to not P is the contrapositive. Okay, you flip-flop the P and Q and put not in front of them. So if you cannot check out books, then you do not have a library card. If you cannot check out books, then you do not have a library card. And again, some of these are the same as we had on Delta Math. Next one, Q to P is the converse. Okay, if we are just flip-flopping the hypothesis and conclusion, that is the converse statement. So if you can check out books, then you have a library card. If you can check out books, then you have a library card. Okay, not P to not Q is the inverse. Not P to not Q is the inverse. So you go back to the original statement and put nots on both. So if you do not have a library card, then you cannot check out books. If you do not have a library card, then you cannot check out books. Okay, and the last one, again, double arrow. That has to be the biconditional. Okay, double arrow. That's the weird one that we don't put if then at the front and the middle. We put if and only if in the middle. So we say the first part as a statement. You have a library card if and only if you can check out books. So you have a library card if and only if you can check out books. Again, if and only if is in the middle. You don't have an if at the beginning and a then in the middle. It's biconditional. Again, it goes both ways. If you have a library card, then you can check out books. And if you can check out books, then you have a library card. Both directions have to be true for the biconditional to be true. Okay, all right. This finishes your homework assignment for 2-3. Again, I'll be interested to know who actually watched all the videos since I literally did every problem with you. Tomorrow, we'll be doing the quiz again.